Yeah, so we'll talk a little bit about that today, primarily in talking through the Watson OpenScale product, which is demonstrated. And then the other part of today is talking about Kubernetes. Actually, let me pull up.
Yeah, that's great. Yeah.
Yeah, so the focus of this week is OpenScale and Kubernetes. Um, I think we're all kind of, if not caught up, close to caught up since we were in that state last week. But any Tracy, Jose, and Glenn, you want to give any quick updates, in terms of what you've been doing with the course? Tracy?
So I'm in my perpetual having read through stuff and scanned through the labs. I skipped week one. I was trying to catch up on week one of course 6. But I looked at that and went, whoa, that's, they even said that's like 2 hours. So I kind of pushed that to the side. And then I got as far as on the Kubernetes one, getting down to the Minikube and saw what was involved in installing Minikube and went, nah, I'm not going to do that on my work machine.
You
It looked like
need to install Minikube if you can install Docker Desktop.
So I did, but I didn't know how to. So like, there's a command right at the bottom about. So you use Minikube service hello node, and so I don't have Minikube on, but I got kubectl on.
Yeah, I thought the write-up was kind of confusing in that regard. We should be able to spend some time on that, on the Kubernetes stuff.
And then I just, so then the other part was I skipped the, I'm on the wrong thing there. Yeah, I skipped the Watson OpenScale. Started, I went through the video and reading and went, no, I'm not going to spend time with it because I'm, by the time I'm ready to use Watson, they'll have changed it already. So I kind of gave preference to this Kubernetes stuff. So about 90% caught up.
Okay. All right, cool. Jose?
Yeah, I think like Tracy, I've done all the reading for week 2 of course 6. Still working on catching up on the work from course 5. So I'm still on the work part. I'm still a little behind, but on the reading, I'm caught up.
Okay.
And I think similarly, I'm focusing more on the Kubernetes and not so much on the Watson stuff for now. Figure at some point if I get figure it out then.
Yeah. Well, I'll give you an overview of the Watson machine learning stuff, which was covered in course 5, and the OpenScale stuff, which was covered in this week in course 6.
Good. We trust you to lead the way.
And Wen, how about you? Have you been working through the course material?
You're still on mute if you're responding, Wen.
All right. Well, he may have stepped away. This week of the course is basically focused on Watson OpenScale and Kubernetes. This second bullet here, implement the basic tooling required to monitor model performance, is basically implementing OpenScale. There's not a lot of independent conversation around monitoring model performance outside of what we've talked about previously. I will let you know that my experience, I saw a tweet yesterday that kind of was foreshadowing my experience. The gist of it was essentially saying, we often talk about 80% of data science is like cleaning up data and only 20% is model building. And so this tweet was 80% of data science is really just getting things to work. and then 80% of the other 20% is your data cleansing. And that was definitely my experience last night. I spent a lot of time banging my head against essentially it wasn't really Watson OpenScale, it was Conda and kind of dependencies and things like that, because Watson machine learning and Watson OpenScale have fairly stringent expectations and requirements for different versions of things. And so in order to get that stuff working, they have, there are certain Anaconda builds that you need to use or requirements that need to be satisfied. And I would, the example uses Spacey and getting the Spacey installed and getting the Spacey dictionary loaded and getting that, running in the same environment as Anaconda is one of these things where I've experienced this before. Like I've banged my head against it for hours and hours and hours and kind of woke up and said, yeah, let me just not do that and try something different. The different thing being just building up a Docker container from scratch that had Anaconda. And that proved to be a lot more fruitful. So I was able to get through that Watson OpenScale stuff this morning. I did not get into the Kubernetes tutorial, but we can pull it up and walk through it together and see how far we get with that.
Just out of curiosity, so of course that your new Docker file is going to be one of the things you're going to throw on the GitHub repo for this class, right?
Yeah.
And you're probably going to refresh that like this week or something?
The
'Cause
GitHub?
I think we have up to week 4 in GitHub still. I did a poll earlier and we were still at week 4, so.
Yeah, so what happened with week 5 is that I started doing like some of the exercises were in Kubernetes and some were in Docker. This was the Spark stuff, and some were local. And so it kind of got all over the place. I started earlier in the week trying to pull everything together and kind of, name them consistently and stuff like that. And I should be able to finish that up this weekend.
Well,
everything pushed up.
You also can just do, we joked several times that it's not really a joke. There are places where we said left as an exercise to the student. You should just put those in the notebooks in big, bold letters, left as exercise to the student.
Yeah. Renaming my files wouldn't be one of those exercises if I pushed everything up the way they are. Quick first topic, again, this is covered in, is one of these kind of sidebars in course 5 that we didn't cover at the time, but it's Watson machine learning. Basically what Watson machine learning is, it's a deployment environment on the IBM cloud for training and deploying machine learning models. And it's based on all the stuff that we've been talking about, Docker and Kubernetes in particular. And so you get, there are Python libraries and REST APIs. You can train a model locally, and create like a pickle file or some other kind of artifact, push that up to Watson machine learning, and then it will create a prediction endpoint for you that you can use to do inference against your model, and will also allow you to do like batch processing and streaming and things like that. So in a lot of ways, it is kind of the IBM service version of what we accomplished with setting up Flask in a Docker container. And so in course 5, let's try this. All right, are you seeing the IDE?
Yes, we are.
Okay, so course 5 walks you through kind of a super high level Watson ML example. Basically, the first step is in IBM Cloud, everything is kind of organized in terms of these resources. And so your first step is essentially to sign up for Watson Machine Learning. That's adding the Watson Machine Learning resource. And then once you, make sure I'm logged in here. All right, so once you have signed up for Watson Machine Learning and created an instance of it, one of the things that you need to do to use it is create a set of service credentials. These are, it's just a file with API keys and stuff like that. And then you take that and you save it as a WML.json file under a .ibm directory in your home directory. And then you can use the client, which you can install via pip and make calls to Watson Machine Learning via Python. And so the tutorial in course 5 has you do all of that, and then they give you a couple of Python files to run through as an example. So it's not a notebook, it is just these Python files. The idea being what we've talked about in the past, that eventually when you're done with exploration and you're talking about deploying models, you want to have a repeatable process that is in a code artifact as opposed to a notebook. And so just a quick run through of this is fairly straightforward. The first thing we're doing is we're connecting to the Watson Machine Learning service. That is basically loading our credentials from that .ibm WML.json file and calling the client with or instantiating the client with our credentials. So then we get a client. The next thing we do is we're loading our avail data that is from this avail target CSV file that we've seen quite a bit of, doing chest train split. And then we're creating a simple processing pipeline that is using doing a random forest classifier, and we're doing some pre-processing. This is the usual stuff like one-hot encoding and imputing missing data. And then we're fitting the pipeline and printing the prediction report. That's kind of informational. The main thing we're doing here is we're deploying I don't think we actually use this. We're deploying the model here. So model deployment details equals, I guess this is assuming you already have a model ID. But client.deployments.create, you give it a model ID and a name, and then that will basically take this model that you have created and push it up to the Watson Machine Learning. And then the next.
Is there a reason they hard-coded the UID rather than calling UUID to generate one on the fly, do you think?
Yeah, I'm looking at that. I think I'm also wondering the connection between this model that you've trained here, that is your pipe, and I think is that all this stuff here? Oh, yeah, I don't know why this is commented out. Maybe this model UID is like in their account, and so they're just showing it to you. They're having you replace something in their account or something. That is kind of weird. I think in practice, you're setting some metadata here, and then the first thing you're doing is you're storing the model, and pipe is the model that we just trained. This is the metadata. It's just like names and stuff like that. And then this stuff would be commented out here. So your model details is going to come from the store model request or command. And then that's going to give you, you're going to get your model UID out of that. And then you're going to create a deployment of your model. Does that make sense?
Yeah, mostly.
Yeah.
What somewhat doesn't make sense?
I guess because I haven't really researched, I didn't study what's going on the other side, what's going on the IBM side of it. So, you know, since I don't know exactly what the deployment is going to be doing, I have questions about, like, did they hard code the UID because you're going to constantly replace the model, or, you know, so just little details like that.
Yeah, yeah. I think the idea is that the kind of the life cycle is that when you're first starting, you'll set up this metadata, you'll name your model, and then as you train a model, there are kind of two key concepts. The first is the model repository, where you're storing the actual model, and then that's this kind of this repository piece. And then when you're doing a deployment, you're basically telling the Watson machine learning cloud to, like, create an endpoint that points to this artifact that you stored in the repository. And then the test model is fairly similar. You are connecting to the service. You're getting your instance details, so kind of a connection string, if you will, from the client. You are loading your data again. This step is having you list models and UIDs and stuff like that. And then this is, we're getting model details for a particular model. We're getting details for...
Except you're not, because you abandoned at that point.
If we didn't. And so this is all kind of meant to be a little refresher of the stuff from course 5, and we'll actually pull it up in a second when we go into the OpenScale notebook. But yeah, I'm not sure why they had these test files quite set up like this, but really they're giving you a place to start playing with this stuff. So once you have a deployment, then you can get a scoring URL from that deployment, and you can score by calling this score function, giving it a endpoint URL, and sending it some data. And this also seems kind of weird because we haven't defined these. But the general, again, taking a step back, the general idea is there's this concept of a repository. You push a model to the repository. There's this concept of a deployment. You create a deployment which sets up an endpoint. From your endpoint, you can get a scoring URL, and then you can use the client to score by giving it the scoring URL and the data. The main things that I wanted to show here. And then when we get to, so that's kind of Watson machine learning. And then what Watson OpenScale is a product for basically model monitoring. So they've got a bunch of different use cases: performance monitoring, quality monitoring, fairness, explainability, drift monitoring. And they're exposed in the tool as 4 main areas. There's a dashboard. You can dig into the dashboard and get things like explanations. There's configuration and support areas as well. One is asking, can we wrap the models as a Docker image? What I saw was doing things via Python. I'm not sure that you would use Watson machine learning if you can submit Docker, already Dockerized images via Watson machine learning, but that's something that you can take a look at.
So it means that when we have the model and on the code, and we can use some other tool to Dockerize the whole thing to the Docker image, and maybe push on some private Docker hub.
Mm-hmm.
Okay, yeah. Okay. Thank you.
Yeah, I think that they talk about it as being built, on Docker. I don't know that you can refer to your own image using Watson machine learning. I am nowhere near an expert in it. I've kind of gone as far as the course materials had us go. So we can kind of flip through the docs here. But that level of detail wasn't really covered in the course.
Yeah, we can figure out later about that.
Okay.
Yeah.
So that's WML, and then Watson OpenScale builds on that. So there's a tutorial for Watson OpenScale that we can run through. This isn't really part of it. A lot of my problems came with basically with Spacey. Spacey's an NLP library. We've used it earlier in the course when dealing with this movie reviews database. And when you use Spacey, you have to load a model, and all of the versions have to line up correctly. The version of your model, the version of Spacey, the version of the other things in your environment that you need to do to get it all working. So I mentioned my ultimate solution was to just spin up a Docker container, and that's where this is all running from here. It's pretty basic Docker file that builds on top of the official Continuum Miniconda creates a Python 3.6 environment, installs Jupyter, installs requirements via pip, and then downloads this Spacey dictionary. And that basically got me to being able to run all this stuff. And so this process, the beginning of this is stuff that we've seen before. We've got our movie reviews data in a CSV file. Basically this is the task here is sentiment. So the labels are positive and negative sentiment. We are getting our training data from the review column of the data set, and we're getting our labels from the label column of the data set, with the caveat that we need to rename the label column because you can't use a column that appears as a token in the corpus. So we put these asterisks around it. One of the things that none of their examples do is they all, when you go from these binary strings in pandas to the data set, the B ends up being prepended into the string. And so I added this little bit, as I've done in previous notebooks, that basically says if that B is there, just get rid of it. And then, as opposed to saying B Arnold, B Good, B Quaid, you get clean phrases in your input data. And so now we're splitting that up in the test train split. We are setting up a TF-IDF vectorizer. We did this in, let me get rid of Slack here. It's a little noisy right now. We did this in course 3, if you'd like to review it. This was the, I think it was the clustering notebook. It was one of the notebooks in course 3. So we set up a TF-IDF vectorizer with 1,000 features. We train it using fit and transform. And then you get this, this dense matrix that is our training data. And dense here is meaning it's a dense representation. It's not a sparse representation of the data. It's still fundamentally sparse. As you can see, there are lots of zeros. But then what we do is this is all unordered. So we want to sort it so that we can match the words up with the coefficients. That is this code here that sorts the 1,000 terms in our TF-IDF dictionary. And then we are converting it to a pandas data frames, or pandas data frame rather. So after all this stuff, we've got this trained TF-IDF model for the top 10,000 terms in our data set. We're observing that a lot of it is sparse, and so a lot of those words aren't going to be strongly correlated to whether the review is positive or negative. And so we're going to identify the 200 most significant words, or in particular, the 100 most significant words that are indicative of positive review and the 100 most significant words that are indicative of negative review. And in particular, those are the words with the highest magnitude coefficients in our model. So we build our classifier here. We fit the classifier, print out the accuracy and the confusion matrix. Then we do this sort on we get the model coefficients and pull out the 100 the 100 largest positive model coefficients, or not positive coefficients, but the 100 largest coefficients corresponding to the positive features, and the 100 negative ones. And then we basically line that up with our array of the sorted words and pull out the significant vocabulary as being those sorted words that correspond to our 100 positive features and negative features. And then we're printing 20 of those. So having done that, we are building a TF-IDF vectorizer just on those words. So we're giving it vocabulary equals significant vocabulary and then fitting it on the training data like we did before. And then producing these train and test TF-IDF matrices just like we did before. And even just looking at it, we see that we've got more non-zero entries here. So it's a little bit more, a little bit less sparse. And so with this, we are dumping out a pickle version of the model and converting to pandas data frames and showing a little bit of the data frame. And then we are taking our training data and spitting it out to a CSV file, which we'll use later to work with OpenScale. And now we're, so we've kind of recreated a lot of what we've done thus far. Now we're going to train the classifier again, but on the more compact data set. If we go back up, we see that our test score was 0.836 up there, and now it's 0.818 down here. So it's still pretty good, but we're only using 200 as opposed to 10,000 feature words, so a lot less data. And so now we're starting to get into Watson ML. We talked a little bit about the credentials, and this is all just setting up the service. So we've got our credentials set up. Now we instantiate the client here. And then we're listing models. So it is making a call out to Watson Machine Learning to see what models you already have. When I first ran that, there was nothing there. Now you can see I've got a couple of models there. One is a German credit risk model, which is deployed as part of the Watson OpenScale demo. And then the other one is this model that we'll be deploying in the rest of this file. And you can see that the fields that basically the metadata associated with the model repository is this GUID that we saw earlier, the name of the model, the time, and the framework that it's using. And so this is ultimately where that GUID would come from that we were talking about earlier, Tracy. So we trained our model back up here, significant model. We're just going to look at it. We see it's this SGD model. We build a metadata dictionary naming our model, telling it the framework and the framework version. And so then we're storing our model, giving it the scikit-learn model and the metadata. We get that model UID, which is this GUID, and then we can list models again. If I did that, there would be the two models still. And so now we're going to deploy the model. So we call create on deployments. We give it a model ID, so a model is already in the repository, and a name, and then we'll return some model details, of which we can pull out the deployment ID. We're printing that, and we're printing a status on that, and so we get here another UUID and a success message. And so if we client repository. So the previous thing we called was list models. Now we're just calling list on the repository, and this is showing us our deployed models. And we've got a couple, these are both the same model. The same scikit-learn, different versions of the scikit-learn model. Okay, and so now we're gonna do a little bit of testing. We create a good movie review, just some text here, really love this movie, blah, blah, blah. We still need to put that good movie review through the same feature engineering pipeline, you know, as simple as it is. In this case, we need to lemmatize and transform it to a dense representation, turn it into a pandas data frame, and then get the columns out of it. And so once we have done that, this is what it looks like. And then we can create a payload of values that is, the field is our list of columns, and the values are the values that we created just above. And then we get the scoring URL, which is from the deployment details that we got after we did our deployment. I think this is all still in, oops. Yeah, so this is, we're calling this using the Python client, but, we could use curl and just call this scoring URL and hand it a payload, which is, will be transformed to JSON from a dictionary. And then we get this as our result. It is basically giving a prediction, which in this case is 1, and it's giving us a list of probabilities across our labels. So the probability of a 0, 0.2, or 0.02, and the probability of 1, 0.97. And then we're doing the same thing with the bad review, just to see if the model can tell the difference. Here we're predicting a bad review, very confident about that. So this stuff is all kind of another, notebook version of working with Watson machine learning, all to kind of set up part of what we do with OpenScale. Any questions on any of this stuff before we jump into the OpenScale part?
And so this only took you an hour, right?
Once I got this Docker container figured out, this only took probably, half an hour to go through and kind of understand what it was doing.
I'm just laughing because I looked at the estimated time on the course, and they said, "Yeah, this is an hour for this."
Yeah, this has been my experience, and it's why I mentioned this tweet. It's not just my experience. Like, most of my time in the latter few courses in this sequence have been banging my head against infrastructure and tooling as opposed to, anything that we would call real data science. Like, yeah.
That's totally my experience as well. So I think, I bet Jose and Win, I bet you guys, same thing, right? It's all this background infrastructure configuration and debugging.
Yeah, absolutely. Always trying to figure out, get the requirements to work. I spend a lot more time on that than I do on the actual code.
Yeah, so we, now we have a model that's deployed. We can call it for inference. Now we're gonna start to play around with Watson OpenScale. There are some steps to set that up. I am not going to. Log out. All right.
By the way, thanks for doing this again, Sam. It kind of, I had just glossed over that, but now that I see what the project is about, I'm sort of motivated to go back in and do that part of it.
Yeah, I mean, it's pretty interesting, and it's I think, even if even if you're not using Watson today, I think there are similar, the principles are similar across any of the cloud services that you might want to use. So there are some steps to setting up Watson OpenScale. They are fairly straightforward. The only there are some things that, to your point earlier, Tracy, about by the time you use it, it'll change. There are some things where the UI had changed since, and actually we can maybe even do it. I forget how long this took. I think I've deployed the only thing that I can deploy. So let's skip that for right now. The main thing that you do is you basically have to kind of add OpenScale as a resource in your cloud. I talked a little bit about that in the context of Watson machine learning. It's kind of the same process. Then you go to the OpenScale homepage, you launch an app. The first thing they have you do is click this auto setup, which is basically a demo mode. And they've got a really good tour of OpenScale, which will actually run through, because the clicking around the simple model that we have, there's really nothing, there's nothing there yet, because we haven't run any tests, or it's not, we don't have a lot of data. But you can, I did not delete the test data, which is based on this German credit risk model. You may remember we looked at this German credit risk model in course 2, I want to say, when we looked at the AI Fairness 360 toolkit that IBM made. And there's a lot of overlap actually between what that is doing and what Fairness 360 or what OpenScale is doing, and that one of the components of OpenScale is monitoring for bias and fairness. And so there is actually a pretty cool, not that. There's a pretty cool feature in this that will, oh, if I can find it. No, where did it go? What's the name again? Sorry.
I love the fact that Stack Overflow is right there in the list of in the menu.
Yeah, I think they have like a sponsored Stack Overflow thing that's like their main forum for this. Oh, there's a really cool thing that you can, if I can figure out how to trigger it, that will basically do a tour of the interface. So what's new? Maybe it got rid of it because I already went through it or something. Let's see if it's here. Use the tour. Oh, I was hoping that would tell me how to get back to it. Well, basically, this is your dashboard. I've got two models deployed, and this is the model that we just deployed via the notebook that we just went into. It's actually, I didn't mean to click that. It's actually fairly boring because there's not much there yet. So we'll go back to the dashboard here. And so we can click on this German credit risk model, which has a lot more interesting. Is that telling you how to start the tour? Is that what that link is that you sent, Tracy?
Sorry, I had to unmute. Yeah, it just says getting started tutorial, and there's a link to a video detecting and correcting AI model drift with IBM Watson OpenScale. I don't know if that was the.
No, there's when you first install the demo, and I'm not going to do it now because it takes a while to install because they're installing data and stuff like that. But there's like a click tour where you can click through all of the different aspects of the user experience here.
Okay. Well, so keep an eye on it when we do it ourselves then.
Yeah, definitely walk through that tour when you do it yourself. But basically, it allows you to monitor fairness, quality, and drift. And so in the case of fairness, you're setting up a monitored group, which in this case is female, and it is tracking the performance of your classifier for your monitored groups relative to the other groups that you've set up. And you can set a threshold, and when your fairness score for your monitor group drops below your threshold, it will throw up one of those alerts on the dashboard. In this case, we are, the data set is this German credit risk model, and the desired outcome is no risk. And so this fairness score is, if I'm remembering correctly, the kind of ratio of female no risk to all no risk, or female no risk to male no risk. this particular one is for age. Sex is the one that has the threshold violation. You can kind of look at it over time. Let's see. And then you can, so this fairness, we've defined the different monitor groups that we want to keep track of. But you can also look at these various kind of training metrics or quality metrics. Drift, this is basically keeping track of the change in accuracy over time. And again, you can set a threshold and get alerts if you drop beneath a given threshold.
So we talked about this last time, but I mean, one of the problems that you have with testing for drift is introducing new labeled data, or is it that you always keep a withheld set of data, of test data that the machine is never trained on, and you're constantly reusing that test data to look for drift?
No, it wouldn't be that, because if you are using constant test data, that probably comes from some test train split that you did, and assuming that it was random, you know, it should be in the same distribution as your training data, so you wouldn't have any drift. The drift, I think, is relative to the data that your model is seeing once it's been deployed.
Versus if the model is retraining, you know, as it goes along. So if it's, so drift could be caused because you're bringing in new data, but then again, that would be labeled. So no, never mind.
Yeah. I would like to ask more about this part too, because this is related to how the model perform in the real application. So you have the new data, and your model makes some prediction, and of course that you need to have the raw truth, so you can compare the accuracy of the, you know, how the model performing. So I would like to know how you sample that, and do we need to check every new samples?
Yeah, we got into a conversation, one and a few others on Slack about this. I think for there's two questions here. One is how it's done in Watson OpenScale, and you know what the implementation is, and then there's more generally. I think there are different types of things that people will track in practice. There's looks like one lost his audio. Maybe I'll pause for a sec. Let me know if you actually can hear me, but the Zoom thing is saying you're connecting to audio. When are you back?
Yeah.
Hi, I can hear you.
Okay. So I was saying that I think that, you know, there's one thing is the Watson OpenScale implementation of this. The other is, you know, what folks do in practice. I think there are, once you've got a model that's deployed and it's getting new data that you haven't seen before, there are a couple of ways that folks are, you know, several different ways that folks are kind of keeping track of drift.
Like add the feedback group, how to add the feedback loops, something like that. Yeah.
Well, one is like, a feedback loop, like explicit feedback. Like I think the example I gave in the thread was like, I don't know if they still do it anymore, but a few years ago when Facebook was trying to figure out how to do facial recognition in your photos, they'd have this thing at the top of your timeline or whenever you update a photo that's like, hey, is this Mary? Is this John? Is this Joe? Whatever. And so they're basically asking the user to rate the job that their models did through an explicit feedback loop. Through a feedback loop based on explicit feedback, or a loop based on explicit feedback. So that's explicit feedback. You can also use implicit feedback. So like if you're Netflix and you recommend a movie, there are all kinds of different implicit feedback points. One is if the person you recommended the movie to, does or doesn't actually watch the movie. Another is, how far they made it into the movie. Maybe you have learned that people that really like movies watch them in one sitting and people that don't watch them in multiple sittings. So it's, there's stuff like that. So there's all this kind of implicit data that you can use to determine how well your model is performing and, ultimately create a baseline on that implicit kind of feedback data. And then the other thing that you can do is, once you've collected a bunch of data, go back and actually label that data and, periodically see how your models are doing.
You mean all of that?
What's that?
I mean all of that, all of the due data. We have to keep track.
I don't know that it necessarily needs to be all of the data, but I think you need to be careful about how you sample. Just like anytime you're doing statistical sampling, like if you say you're monitoring for drifts, weekly. You don't want to collect all of your data, that,
right.
Late at night on a weekend or something like that. If your
Right.
people, your users are most active during the week, you want to kind of sample kind of evenly, or at least thoughtfully, and then use that to determine the accuracy of your model.
The technique or some material to show how to sample the right way so it's not biased, something. That may be off the topic, maybe later.
Maybe a little off topic. I think.
Yeah.
I think from a stats perspective, there's like, that's the kind of thing that might come up in a lot of basic stats books, just like the concept of bias. I think, the main thing is probably being conscious of like, I think being conscious of like seasonality and those kinds of issues, and also just being consistent, when you're sampling from one period to the next period.
Right. Yeah, thank you.
Yep. And so in terms of OpenScale, let's see if there's any more information that they provide here. How it works. So Watson OpenScale creates the drift detection model by looking at the data that was used to train and test. The model has an accuracy of 90% on test data. It means that it provides incorrect predictions on 10% of the test data. So OpenScale builds a binary classification model that accepts a data point and predicts whether the data point is similar to the data that the model either incorrectly or accurately predicted. So it creates this drift detection model, and at runtime it scores the model. This isn't maybe the same as the accuracy, drift and accuracy, because we've talked about this in last week. I think last week talking about, so the conversation we were just having, I think that question kind of arose, if we want to compare accuracy from one period to the next, with new data, how do we do that? There's another question, which is, okay, we're not necessarily trying to trying to test accuracy, but we just want to know that our model is seeing the same kind of data. Then there are things like novelty and outlier detection that we've talked about that you can use. And I think this model of building a classifier is kind of along those lines. Well, let's keep going here. So once Watson OpenScale creates this drift detection model, at runtime it scores the model using all the data that the client model receives. For example, the client model receives 3,000 records in 3 hours. It runs a drift detection on those same 1,000 data points. It calculates how many of the records are similar to the 10% of records on which the model made an error. 200 similar. Then the model, it implies the model accuracy is likely to be 80%. Because the model accuracy at training time was 10%, or sorry, 90%, means there is accuracy drift of 10% in the model. That's kind of an interesting way to do it. Does that make sense to everyone? Basically, what it's doing is it's classifying the data that is presented for inference into likely to be, similar to the training data and not similar to the training data.
So this makes me think of, obviously I look at everything through the lens of melanoma. But one of the tools that people are providing now is, rather than tell you have melanoma from a picture, they basically find all the other pictures that look like your picture and say, here's what things that look like what you have were rated as. And so you can see that 8 out of 10 of them were melanomas, for instance. Mm-hmm. So they don't tell you have melanoma. They just say, this is what it looks like. So it sounds to me like that's what they're doing here. They're saying, it looks like these other things and they were rated this, so therefore we're going to vote in. It's kind of a hot.
I think it's similar to that, but what this surrogate model is doing is saying, okay, does the data that we've received, is this data that we think our model knows how to predict well, based on what we've seen in training? And so if we got if we got 1,000 data points, then it is going to calculate how many of the records are similar to 10% of the records on which the model made an error. It's going to look at the model. It's basically going to try to predict how many of those 1,000 data points are similar to the data points that the model struggled with. And so once we do that, if 200 of these records, so they're saying if 200 of the, if 20% of the records that were evaluated in a given period of time are similar to the 10% of the records that the model would struggle with during training, then the model accuracy is probably going to be 80%.
So it's not so much that the model has drifted, it's that the data distribution has drifted and your model. So they're predicting that your model is not keeping up with the drift in data distribution.
Yeah, I mean that's what the drift is all about. The idea is that you've got a model in production, and the model's not changing, but your data may be changing. You know, you've got a model at, you know, your online web store that says that, you know, when someone comes to, you know, your homepage, they probably, you know, want to buy toys and books and don't want to buy masks, you know, and then a COVID happens and now everyone wants to buy a mask. Well, your model hasn't changed, but it's out of date because the context in which it's running has changed. And that's what we're trying to predict. We're trying to identify when that happens, and also find ways of estimating the accuracy of your model at, you know, runtime, even though we lack labeled data, unless we collect a bunch of data and then go label it. And so the method that OpenScale is doing is, and I keep saying this because I'm trying to kind of work through it in my head, we're collecting a bunch of data in real time, you know, again, 1,000 data points. Then we're running a model, we're applying a classifier on our model to see if, you know, how many of those data points are similar to data points that our model found difficult in training. So in other words, we're using a classifier to figure out how many of the 1,000 data points that we collected in the past 3 hours was our model likely to have gotten wrong. And if, you know, that is 80% of our data, then the, you know, then that says that, rather, if that was 20% of our data, then that says that our model was probably going to get 20% of those points wrong, and conversely would have 80% accuracy. And if our train time accuracy was 90%, that means that the accuracy has drifted by 10%.
So the confusion for me, I think, comes when they keep talking about drift in the model. And I know this is like relativity here, you know, who actually moved? Did the model move or did the distribution move? But in this case,
so
what they're
saying, detecting and correcting AI model drift.
But the model is, in this case, the model static. And then the confusion also comes because there are some models that you do change. You are constantly evolving the parameters of the model in real time as new data comes in. So those models are changing models, and the model itself could drift even though the data distribution is not drifted. So there are two types of drifts really that can occur here. But I guess from a pragmatic standpoint, it really doesn't matter. You know, if the two things have drifted apart, who cares if you moved or I moved? The point is we're no longer in sync.
Right. I think when you're talking about a model that you deploy where you're changing the parameters, does that mean outside of training?
I'm drawing a blank on the terminology, the name here, but it's continuous retraining, right? So it's they're like some of the one-shot training algorithms that every time you get a new piece of data, you actually modify, or a lot of the stuff, even in Apple's ML stuff,
Online learning, that kind of thing.
Yeah, online learning. There we go. Thank you.
Yeah, and so I think that probably, you know, that's an example where this, you know, it might require a different approach. You know, as I'm thinking about this approach that OpenScale is taking, it kind of makes an assumption that your right? It's looking to see if your model, if your incoming data looks like data that your model did well on or didn't do well on. But what if your incoming data doesn't look like any of the data that your model's seeing? Then, you know, how well is this method of estimating accuracy going to work?
The open set problem.
Yeah, so I think, you know, this is kind of one of several ways to try to detect and assess model drift. And if you're, you know, doing something like online learning, there are probably other techniques to try. And, you know, separate from these kind of assessment tools, you know, there's the stuff that I mentioned previously, you know, implicit and explicit feedback and labeling ground truth and, you know, testing it after the fact.
Now this is cool and it makes sense and I get it. I just wish they'd named it something different.
Mm-hmm. Oh, am I logged out again? So I think we were looking at this credit risk model and some of the fairness tools, quality tools, and drift tools. I would encourage you to go through, you know, either I think they have a video there that someone shared, or actually just get the sample data, you know, load it up and kind of go through the tour. It's kind of interesting, interesting stuff. I mentioned that our deployed model that we did through the notebook, there's not a lot here. Yeah, I was thinking about maybe just blowing it away and walking through the process of getting it up, but actually let's move on to this Kubernetes stuff because there's, I have not gone through that yet, and it may take a little longer. But this is the kind of the first exercise here is this notebook. And so the next piece is Kubernetes, and let's see. I think I've got that notebook.
So can you talk a little bit about what the reason we have to use the Kubernetes together with the two OpenScale?
I think they're separate topics. I think OpenScale, so there's Watson machine learning, which is a training and deployment or training and inference system that runs on top of Kubernetes.
Yes.
There's OpenScale, which is a machine learning monitoring or model monitoring.
Oh, yeah. So, yeah, right.
That's separate from Kubernetes. And the stuff that we talk about for Kubernetes, I think, is separate from either of those.
Okay.
This is a little bit of a background. There's a video about Kubernetes in the course. I thought I went into a bit more detail than was necessary for what we're trying to do, but it was useful. I actually wrote an ebook on Kubernetes for ML and DL, and I'm in the process of updating it. This picture came out of the first version of that ebook, but basically what Kubernetes is a cluster management system that allows you to easily deploy containerized workloads across the cluster. So you've got a collection of nodes. Nodes are servers. You've got a collection of, so you've got these servers, and then you model your workloads as what they call pods, which are basically a collection of containers that can exist. They have to stay together on a server. And a big part of what Kubernetes is doing is allowing you to, it's got plugins and other things that figure out, what the different capabilities of your servers are. So say you've got, 100 servers and 20 of them have GPUs. Kubernetes can, learn that. And you can say, I've got this pod with a training container in it. I need to deploy it out to 5 nodes, and those nodes have to have a GPU, or a certain kind of GPU, or a certain amount of memory, certain number of CPUs, cores, etc. And a big part of what Kubernetes is doing is what they call scheduling. So basically managing the distribution of these pods across the nodes that you have available, so as to ensure that all of your requirements that you specified for your nodes are met. And you've got these ideas like replicas or replica sets. That comes up a lot when you're scaling. So say you've got a distributed training workload that's got a container that is using, some kind of distributed training feature or capability, like Horovod is an example of one that comes up for training TensorFlow. You can tell Kubernetes that I need 10 replicas of this pod, and they all need to have, GPUs. And again, Kubernetes will figure all that stuff out. You've got concepts like namespaces that allow you to kind of divide up your cluster logically across different users or teams. And there's also another interesting or important concept is the idea that each of your pods will have a IP address, and part of what Kubernetes does is it does like network level routing of traffic to your pods using essentially load balancing. So when you can spin up a pod that exposes like Flask endpoint, and Kubernetes knows how to route traffic to your pod independent of where it happened to have put it on the cluster. Kubernetes is administered through this tool that you've probably come across called kubectl. So when we go through this tutorial, that will probably come up. Let's see. All right, so, and again, I apologize that, as I mentioned, I did not have an opportunity to kind of go through any of this stuff because of all of the.
Well, you're gonna laugh because this is like the shortest of all of the tutorials, unless I missed something.
So yeah, I haven't messed with Minikube at all. Basically, Minikube allows you, it's like a self-contained Kubernetes cluster. But if you install Docker Desktop, when you install Docker Desktop now, there is a Kubernetes environment that it creates for you. And so this isn't necessarily a clean start because I've used this recently, but I don't necessarily know what state it's in. But we can hit enable Kubernetes here to turn this on. This Docker stack thing isn't important for us, but just want to keep it as clean as possible. And so we're going to enable Kubernetes and then apply and restart.
So this takes a couple of minutes to crank up. So while it's cranking up, so when I went through this, because I have, I've got this installed now. The fly in the ointment for me was they presume that you've got that mini cube or whatever that thing was called, and that's how they're controlling it. Once you kind of install something on this, I guess, this server, then you're supposed to control it with that other tool. So I'll be curious how you manipulate it without using that tool.
Okay, let's see.
Yeah, there's a step right at the bottom where they call kube control or kubectl to expose deployment hello node, and then they expose it, that load balancer you're talking about on port 8080. But then you have to activate it with minikube, and so that's the new missing step.
Got it. Okay. I don't know why. I don't remember this taking quite this long.
It took quite a while last night when I enabled it and rebooted. I mean, quite a while was like 4 or 5 minutes, not half an hour.
Okay. Yeah. I've been running into problems. I use this thing, Little Snitch. I don't know if you ever come across that, but it basically allows you to, it's like a firewall on your Mac that prevents different things from pinging out. And I recently discovered that something that I banged my head against the last time I was messing with all this stuff was caused by some rules that got set up that was blocking connections. So I just quickly opened that up.
Always the little things.
It's always the little things. And unfortunately, they are mostly always self-inflicted. Well, I was thinking.
Or maybe you can look ahead and walk through what's going to happen so that when we actually do it, it's...
Yeah. So, oh, there we go. All right, so I got green lights here. So then let's This is basically telling us that we have kubectl kubectl installed in our version. Kubectl cluster info. Is it talking to a cluster? Yes, there's a Kubernetes master running at Kubernetes.docker internal 6443. And then kubectl get nodes is going to show us our nodes. We have one, and that's this Docker desktop. That's the node that Docker desktop spins up. And then ctl, let me look at this also. So then there's kubectl get pods, which will show us our pods. There's no pods currently. And let's see, kubectl get namespaces, default Docker. All right, so this looks to be pretty fresh. Now, if I can remember correctly how to do this. Oops. Trying to remember how to get the dashboard up, because that's kind of interesting. So let's see if this will do the trick here. So need another window here. So basically with Kubernetes, it's the part of the idea is that you're able to deploy these systems declaratively, like you specify the configuration that you want the system to maintain in a configuration file. They're YAML files, you know, and those map your containers to your pods to requirements, and then Kubernetes will do what it needs to do to make all that happen. And so when you're trying to deploy a new service, you're basically applying a YAML file. And maybe something else that I need to do in order to do this, but let's just see if we can get up the dashboard. And what is the and so this is an example of just hitting this, hitting the Kubernetes kind of, this is the API endpoint. And then there's a dashboard URL that you can hit. And it looks like the dashboard is installed correctly. And so now we need to get a token. And let's see.
I was on a different screen trying to copy stuff down. How did you bring up the dashboard?
All right, so the first step is to spin up this kubectl, well, I don't think the order is all that important here, but you need to, here, you need to basically deploy the dashboard. That's, you're basically deploying a YAML file from a GitHub repo. So it's this kubectl apply -f and then the dashboard YAML file. And this you can Google those steps. And then you have to have the kubectl proxy running. And then you hit the dashboard endpoint, the URL, and that also you can Google for. I can, let's see, put these in my notes too. All right, so then it's asking you for a token, and the tokens are, so if you do kubectl -n, so everything in cube, remember we did kubectl get namespaces. Everything in Kubernetes is namespace. So if you tell it to, if you want to try to get a resource, you have to tell it a namespace, or else it'll tell you it's not there. So get secrets -n cube system. And so Kubernetes has a secrets API, and we're telling, basically kubectl allows you to do things like apply and get, and you can apply these different things. You know, you have like, these are your verbs and these are your nouns, namespaces, secrets. These are examples of like built-in APIs, pods, get pods, describe pods, and then when you deploy things, you kind of add to the Kubernetes API. And so you could, you know, kubectl get and some new thing that you created through a deployment. But for right now, we're just trying to find a token that we can use for the dashboard. And I think we can use this default token thing. So then we would do like a kubectl -n cube system describe secret and actually let's say this, where did it go? Default token 7DSW8. And so this is a token here. Let's see if this one will get us into the dashboard. Cool. So the things that we did here are, we did the kubectl get secrets to get a list of our secrets, and then kubectl describe to describe a specific secret, which we then copied the token and pasted it over into the dashboard login page. And so now this is giving us, again, it's all namespace, but this is giving us an overview of the, we can look at the nodes and we can look at the pods. There's nothing in our default namespace. We don't really have anything interesting here to look at, but what we can do, well, let's go back to the thing here. So we've looked at nodes, created and verified we will create a deployment using a simple hello world example from Google Container Registry. All right. So, oops. So this is this create deployment. Deployment is another one of those nouns that we can create. We're calling it hello node, and we're telling it that it can find the image at this URL at the Google Container Registry. So let's see, and so now we have a problem. And the problem is consumer permission denied. So basically it can't pull this image for some reason. So let's see if this is still around. Permission denied. This project has been suspended. So maybe this thing is just so out of date that Google turned it off or something. So let's do something else.
You mean there are like errors and missing stuff in the course materials?
What's that?
You mean there are errors and missing stuff in the course materials?
Well, I
I
think
never believe it.
They're trying to do something simple, and this is maybe out of date. Let's maybe go and probably do hello cube. What is it? Hello mini cube. Oh, let's see. Create a mini cube cluster, create a deployment. It looks like this may have just moved. So let's try that. So hello node already exists, so we need to do kubectl delete deployment hello node. All right, and so that will hopefully let us create that deployment.
That was the other command I was looking for. I didn't know how to delete the node once I had sort of installed it.
Mm-hmm. And so now we've got this deployment. The deployment has a pod, and the replica sets is just the way Kubernetes keeps track of. We told it we wanted 1, and they're currently 0. That's why it's yellow. So all of this stuff is working itself out. Let's see what the status is here. Pulling image, so the image is pulled. Let's go back to, looks like the pod is there. Let's go back to our overview. Oh, everything's green. So we've got this. Let me copy over this. So we want to use this this instead of the thing that they had in the materials. All right, and so now, you can, so we've got the deployment, we can do kubectl describe deployments. And so there's just this one, hello node. It's got some labels. Labels are like tags that you can apply to different things. This is an app label. Tells us where the image is. Tells us that it's been up for 105 seconds. And so next thing that we're going to do here is kubectl, kubectl expose deployment hello node type equals load balancer port equals 8080. So let's, hopefully that port isn't being used. And so when you activate the service, you should see the URL of the cluster server in the terminal window, and it will open up a web browser pointing to, so kubectl would be create service hello node. Let's see. So we don't need all this. We're just looking for the analogous. So we're not using Minikube here. So we're trying to adapt the adapt these instructions for kind of a full-blown Kubernetes environment. So what we want to do is kubectl get pods. And so this gives us the name of our pod. And this -o wide looks like it's giving us a little bit more details, but nothing. Oh, that's the node IP. And so see if that's going to work for us. It's working from the worker node. Yeah, that's not actually going to work because we need to get to that. And it's not exposed. So this example that they're doing, they've actually connected to a pod, and yeah, actually, if I remember correctly, we might be able to do that in the dashboard, and the dashboard will tell us the command line for it. Okay, so here now we're in the pod, and if we do the same thing, or uh-oh. Let's see. All right, that's not working. So let's go back to our node here, our pod. What we ultimately want to do is create a way to basically expose the service out to the outside world. And so let's try this. Expose deployment. In our case, it is, that's our deployment. Wait, no. We want the deployment. So let's do kubectl get deployments. So just hello node. So kubectl expose hello node. Reference server services hello node already exists. Oh, well, then we should be able to use this. Yes or no? This is where we get to the 80% of just trying to get things to work. Oh, well, first of all, I didn't specify the port, which is stupid. It doesn't look like it's helping.
And this is why I said I got stuck at the mini cube stage.
Yeah. There's definitely a way to, oh, you know what? So, all right, the answer, as is often the case, I think, is here in black and white. The cluster IP is IP that is accessible from the cluster. And so we can't, this is in the Kubernetes domain, it's kind of spinning up these private IPs that you can't access. The external IP is just the local host IP of the port of our node. And so, and the port is specified here, 8080. And so we see that this is hitting, and I don't know what this thing that we deployed is supposed to be doing. It's different from the things that Echo server and not hello world or whatever. And so no, this is the Minikube thing. So this may well be what we're supposed to be seeing back. I'm not sure. But the other thing we can try to do, I think that's the end of the exercise here. The other thing we can try to do is take a look at the thing that I was playing around with Spark. I mean with Flask. So I don't remember exactly the state that this was in, but we can try to do kubectl create deployment. Flask deployment. Oh wait, let's not do that because I remember the problem that I was having with that. That was the thing that we were running into, that JSON file format issue. Let's see what we can do with it. Create deployment. Deployment YAML. Oh, sorry. Let's I think this we use apply. So we just did another deployment, this Flask deployment. And it looks like that worked okay. It pulled from an image that I have, example ML app latest. Let's see if I can figure out where that is. That may be not there. No. I think it's this one. So this was that part of the exercise from course 5, week 1, where we created a Flask app that had a kind of a hello world endpoint at / and then a /predict endpoint that loaded a model that is saved as this joblib format. And then we were trying to apply, or we were trying to send it this query string. And I think we didn't originally have these countries in quotes. And it was bombing. So we've got that deployed. And so now we can kubectl describe services. Is that what we were doing? So let's so we've got these two deployments, or actually I just want to get deployments. Did that work? Did that? No. We need to actually, this is our port inside. So that's going to be in our app port 8080. So it's 8080. So this is, I think, the outside. So the containers port 80. Yeah, so target port equals 8080. Type equals. Let's see if this works. All right, so then if we do localhost :9999. All right, so what we did here is we deployed a container that had a Flask app in it. We built it up using this Docker file. Basically, start with a minimum Python image, build some or add some essential stuff to it, install our requirements, expose the port, and this command is basically what it's kind of the entry point, what Docker will execute once it comes up online. This add./app is basically taking all the stuff that we had in the directory, the app file, the model file, the requirements and all that kind of stuff, and adding it into the container as it builds the container. And then once it launches the container, it runs this task, which is basically going to, this is Flask app.run, so it's basically going to spin up a web server on this port. We deployed that into Kubernetes using the, let's go back here, kubectl apply. So we deployed it in Kubernetes, then we just double checked its existence. That's here. Then we exposed the internal port that the web server was running at outside of the cluster. So again, when we spun up that when we spun up this pod is sitting, it's running inside of Docker, inside of Kubernetes. It's got some internal kind of imaginary IP address of 10.something.something. We can't access that in our outside world. And so this expose command basically puts a load balancer. Well, basically first it listens at the kind of the edge of our network, and then adds a load balancer that translates between the port that we're hitting from outside the network and to the target port and the IP address that it knows where our Flask deployment pod exists. And at least the simple part of that worked, which is basically, this is the running Flask app. The next part of this would be trying to get it to return a prediction based on this query. And we can give that a try. That would be, let's see. Curl let's make sure it's so it's looking for either a get or a post. And so so we're specifying a content type. We're saying, specifying some data, and I think that's there. And our endpoint. Oh, and it gave us a prediction. So it predicted class 5, which I forget what the context of this was. Yeah, I don't remember. But of the, maybe it's predicting, I think actually if this is a churn predictor and we're giving it 5 data points, and it's saying the 5th user is the one that's likely to churn. And actually, so if we go back here, remember we had our churn problem in Singapore. So this is a Singapore unlimited subscriber with 20 streams. So maybe the model is telling us that this is the one that's likely to churn of the 5 that we sent. Does that all make sense? Or rather, what questions do you have? That was a lot to go over, and I apologize for kind of winging it and bouncing around. But It also kind of occurs to me that a lot of what is cool about this is hard to see, because like running a bunch of commands looks like I basically, spun up a Flask app, but what's really happening is I've got this cluster that could be somewhere, across the world in the cloud with 100 nodes, and I've deployed my app to, actually, let me see if I can do this. I don't know that this will work.
So often what's helpful is not maybe retaining exactly how you did what you did, but seeing that you did it motivates, it's like, it's that thing where you go, oh, I know I can do it because I saw Sam do it. So now I'm motivated to figure out how he did it or how I could do it.
Mhm.
Versus if you haven't seen it done, a lot of times it's sort of like, oh, it's this just giant black hole. So
Yeah.
there's real utility, even if I'm not going to remember exactly the commands you did, just seeing that you did it. And like, for instance, seeing this, oh, I know there's a portal I can spin up. I need to go figure out how to do that.
So I'm going to try this deployment, Flask deployment. I'm not sure if I've got enough resources here, but so I just told it that I wanted to, I don't know if you caught that, but I just told it that I wanted to scale the number of replicas of my deployment to 3 from 1. And so now if we look at the deployments, there are 3. I told it basically I want 3 pods. Now there are 3 pods. And what is potentially cool here is this MJ5V thing corresponds to one of the pods, right? So this is essentially a, analogous to a node. It's
So if you refresh this several times, we're going to see that host name maybe change.
I'm hoping, but then we get, there we go, right? So that's what
Okay, that's cool.
That's pretty cool, right? So
That's
I could
cool.
have had this on, again, across the world. I deployed this thing to, a single node, tested it. Now I say, I've got a bunch more traffic, scale to 10. And then Kubernetes just did that. And I didn't have to touch the load balancer that I set up between, the outside world and the Kubernetes cluster. Kubernetes knew where it put those other pods in, all of my infrastructure, and routes it on the fly, and I don't have to think about any of that stuff. I saw my my dashboard logged out. So yeah, I'm glad that worked, because that's really the, one of the coolest parts about this.
Sam, that's really helpful. Thank you. I think until I get to building it, I won't be able to experience that myself, but I appreciate you walking us through it.
Yep. And so now like the you don't need to mess with Minikube if you install Docker Desktop. It's kind of one or the other. You don't really need to do both.
Thank you, Sam.
Sure thing. So before we part, I wanted to talk a little bit about the project. So this is the last actual course, like the last set of new material that we're covering in this course. The next 2 weeks are dedicated to these capstone, the capstone project. And basically I think it's intended to be covered over the next 2 weeks. The first week there's a bunch of reading material on the all of the prior modules of the course, and then the first of 3 parts of the capstone, and then the next week is 2 parts of the capstone. Basically, I think we saw kind of a taste of this. Maybe it was in, I mean, it's a little bit in all of the previous courses, but I think it was in course like 4, they had you kind of run off and do some exploratory data analysis on a data set and produce a deliverable. I think that's the kind of thing that we're doing for the first part of case study, or this case study part 1. There's a specific data set that they tell you about, and they kind of give you some hints at doing EDA to kind of get to know that data. And then part 2 is doing some time series analysis on that, potentially using tools that we've learned like TensorFlow, Scikit, and SparkML. And then 3 is doing some of the stuff that we did, building a version of an API endpoint around a model and kind of deploying that. And so I don't know if you are all kind of taking the course and going through it in Coursera. Once you create the project, there's a thing that you do where you what is it, peer grading. You submit your project and it's peer graded. And so if you're doing that, then we probably want to work through it semi-independently, because Coursera is kind of expecting you to work through that independently. If you're just kind of auditing and not, you haven't paid for Coursera and all that kind of stuff and you don't care, then I'm totally open to just kind of using the next couple sessions to kind of work through it collaboratively. I think we'll probably still need to do some thinking outside of the time that we have, because it's probably a project that's more than 4 hours. But I just wanted to toss that out there and get a sense for, what you all want to do.
Well, I think for me, collaboratively would probably be better. I had paid for a Coursera subscription, but then this month I decided I'm sure it was fully worth it. I think auditing is very helpful and you can do everything anyway.
Yeah.
So I think collaboratively is better for me. Along with that, I don't know if I almost feel like I need a little bit of time to catch up. I'll work as hard as I can this week so I can be more, provide a lot more input next week. But I don't know how you want to do the collaborative part, if you want to start next week or give us a week to catch up and then start. I don't know. I'm up in either, and we'll crank if I need to this week. So whatever the group wants.
Okay.
I think there's a balance between what you want to do and what you can do. So I think the onus is on me. I want to do this independently first, because that will force me to kind of bump into these, roadblocks and try to get past them, and that will make things stick. But the onus is on me to carve out the time to do that then. So for me, if we do it collaboratively, then for me to do my independent thing means I just need to be diligent, and this week or next week, if we take, a catch-up week, do it on myself. So I think we can have both. Those of us that want to do it sort of independently, the onus is on us to get it done ahead of the collaboration session.
Yeah. Okay.
but I wouldn't mind an extra week.
Well, I would say the first thing that we're doing is going back to the first, first couple of courses. So catching up isn't going to help necessarily with this first week anyway. So I would say that, let's just plan to, work at it, if you can over the next week and get as far as you can, and we'll kind of talk through it next week, and we'll have, we'll all have I guess my experience with the last thing that we did that was kind of EDA oriented. It's not like you're driving towards a specific thing that can be right or wrong. It's like they're like, go explore this data and summarize it in a way that you find interesting and useful. And so from that perspective, I think us kind of speaking, collaborating on it and kind of kicking around ideas, maybe playing with some things, with the notebook up, and then we can each kind of take that back to our individual solutions and add our own flavor to it as we develop the capstone is probably probably a good way to learn, and most aligned with the kind of the way that we would be working out as parts of teams, if not strictly aligned with Coursera's policy, which whatever. So does that make sense? Any thoughts from you, Len? All right, well, I'll assume that that's the plan, and I'll try to be a little bit more prepared to facilitate the conversation around week 3. But I'm glad we were able to get something useful out of this one. I thought the Kubernetes part would go okay. I'm glad it did. So thanks for your patience there.
Thanks again for your help on all of this.
Sure
Thank
thing.
you, Sam. Thank you, everybody.
Yeah, Sam, thanks very much.
All right, thanks.
Have a good one, everyone.
See you guys later.
Bye,
Ciao.
everybody.